Okay, everybody, this is the last video for day 6 sorting. I want to just walk through some of the algorithm that we give y'all so that you have a sense of how it really works here. So I've written up what we have as just sort of a description of what the insert sorted function does and what the sort function does. And I just want to walk through a couple of examples to see what we really mean. Okay, so let's look at insert sorted. So to insert an element I into an already sorted list L, what do? You walk down the list until you find an item greater than or equal to I, then put I into the list. Okay, so let's see what that means. So let's start with a nice example of an already sorted list. Let's say something like 1, cons 3, cons 3, cons 12, cons nil. So I've chosen this list to be short, but not too short, and to be non-trivially sorted in that we have this nice this duplicate right here. Okay, so let's say we want to insert 0. Insert sorted 0 into that. So just diagrammatically, what's going to happen? Well, we need to just compare with the head of the list. And 0 is less than or equal to the head of the list. So really, this is just where we want it. So we'll just put it there, and we should be able to stop right now. No need for any recursive calls or anything. What about 1? What's going to happen? Well, we're going to compare again with 1, and we'll just also do 1 constanta, all that jazz. Let's look at what happens with 2. So now we're going to have a non-trivial walk down the list. So walk down the list until you find an item greater than or equal to I. So this is our I, and then this is our L. Let me get that in a different color. Okay, so for 2, we'll compare. And then 2 is greater than or equal to 1. So what we'll need to do is we'll just compare to the next one too. Okay, now we're less than or equal to. So then what we ought to get is, well, we'll put the 2 here. So we'll get, let me give myself more space. We'll put the 2 here. 3, 3. Right, all that list stays the same. But then critically, we shouldn't forget, we should somehow stick that 1 back on the front. This is the answer we want. So your function needs to do some logic here around sort of consing back on the elements that it's skipping. Let's skip ahead a little. Let's look at 15. So what's going to happen? So we're going to have the list 1, 3, 3, 12 empty list. We'll compare against 1. It's greater than or equal to 1. It's greater than or equal to 3. It's still greater than or equal to 3. It's greater than or equal to 12. And then we'll get to the empty list. It's like, okay, well, great. But if the sorted list you're inserting into is empty, you're good to go. You just return that, right? So we'll just get 15 cons empty list. And then we'll have all of that left over. So then what we want to find is our final answer is something like this. Okay, so hopefully that gives you a sense of what exactly we mean by this function. You're still going to have to do some work on your own to figure out exactly how to implement that sort, or that aspect of the sort. Okay, now let's talk about actually sorting. So what the algorithm says is, given an unsorted list, insert each element into the recursive result of sorting the list. Okay, so let's try it. Let's start with a list. Oops, sorry, bad writing. So we're going to do sort. And let's write 2, cons 3, cons 0, cons 3, cons empty list. Great, some list. We've got a duplicate, so it's not trivial. We'll see what happens. Okay, so this should be the same as insert sorted to sort of the list. Now I'm going to use concrete list notation 3, 0, 3. Okay, well that should be the same as insert sorted to insert sorted 3 sort the list 0, 3. Okay, well that should be the same as insert sorted 2 insert sorted 3 insert sorted 0 sort 3. If it's boring, you know that means you've understood it, so bear with me. Okay, insert sorted 2, insert sorted 3, insert sorted 0. Give ourselves a little more room here. Insert sorted 3, sort empty list. Okay, so that gives you the unfolding. This alone should actually basically tell you what the function does. Sort empty list, well here, that's easy. Sorting the empty list is pretty straightforward, right? Like just return the empty list. Okay, cool. So let's bubble it back up and see what we get. So here we ought to just get the empty list. Right, that's there. Here we ought to get the list 3, right? We're inserting 3 into the sorted empty list. Inserting 0 in, okay, here we ought to get 0, 3. Okay, here when we insert 3 into this sorted list, we should get 0, 3, 3. Okay, and then here we ought to get 0, 2, 3, 3. So sort is really just this, it's sort of folding over the list that you've been given with the insert sorted function. Okay, if you can get insert sorted working, your sort should be super straightforward. Hopefully this is helpful. I'm happy to explain any aspect of this on Zulip. Let me know. This is the last video for sorting. You should watch it second. If you're watching it last, then I'm sorry that it came out last. Because I think this will sort of illuminate what's really going on in the algorithm and is maybe the best thing to do before proceeding on to the sort of what isn't a sort video and the other stuff. Okay, anyway, I eagerly await your questions and talk to y'all soon.